Codeforces conducted a Div 3 contest round 1020, and this was the first problem that was part of the contest. And in this video, I'm going to read this problem, then explain it, and then we will also try to write the code for it. Okay, so they say that in order to test his patient's intelligence, Dr. TC created the following test. First, he creates a binary string S having n characters. Okay, so the first thing that we see here is there is a string S and the string has n characters. So there is a string S and this has n characters. Then he creates n binary strings A1, A2, so on till AN. It is known that AI is created by first copying S and then flipping the ith character, meaning that 0 becomes 1 and vice versa. After creating all n strings, he arranges them into a grid where the ith row is AI. Okay, so let me explain the question first. What they are saying is the string S is a binary type of string. Binary means the kind of characters that the string will have are either 0 or 1. So it will be something like 0, 1, 1, 0, 0, 0, 1, and so on. Next, they say that he creates n binary strings A1, A2, so on till AN. So there is this S string, and then how will A1 string will be created is that he will take the first character of the string S and flip it. Flip it means if the character at that place is 0, it will become 1, and if the character at that place is 1, it will become 0. So if you try to sketch out A1, basically for, let's say, for this string itself, will mean that the character at the first place, considering it as a 1 based indexed string, will become 1, and the rest of the string is going to be the same. So 1, 1, 0, 0, 0, 1. Similarly, what he's doing is he's similarly creating such strings all the way till AN. So let's try a few more. What will A2 be? A2 will be, first character will be as is, the second character will flip. Second character is 1, so it will become 0, and then the rest of the string again remains the same. What will A3 be? The character at the third place is going to be flipped. So 0, 1, 0, 0, 0, 0, 1. A4 will be, character at the fourth place will be flipped. So 0, 1, 1, 1, 0, 0, 1. Then A5 will be, character at the fifth place will be flipped. So 0, 1, 1, 0, 1, 0, 1. Similarly, A6 is going to be 0, 1, 1, 0, 0, 1, 1. And lastly, A7 will be 0, 1, 1, 0, 0, 0, 0. So this is what happens once all of these strings A1 to AN are generated. Okay, then they're saying that after creating all the n strings, he arranges them into a grid where the ith row is AI. So what happens is this essentially becomes a grid. So if this S input string was this, then with some processing, this is the grid that we are getting. Now, the patient needs to count the number of ones written on the board in less than a second. Can you pass the test? Okay. So what we need to do is we need to see what is going to be the number of ones. So if we just manually think of the most basic brute force solution, what will we do? How many how do we calculate the number of ones is we just go over each string, each A1, A2, A3, A4 till A7 one by one, and then at every place of that string we will see how many of those characters are 1. So for example, 1, 2, 3, 4, 5, 6, 7, 8, so on, right? That is the brute force way. If we try to analyze the complexity of the solution, Let's see. So there are number of test cases. Test cases is 1000. N, that is the size of the string, is 10. Okay. So if the size of the string is 10, the number of A strings that are going to be generated is also going to be equal to 10. So overall, there are going to be 10 strings at max in the worst case. And each of these n strings is going to have a length of 10. So overall, if we see for one test case, the complexity will be the time taken to go over each character of this grid, which in worst case is going to have every row of size 10 and the column also of size 10. So for one test case, the complexity is going to be 100, and for 1000 test cases, it is going to be 10 to the power 5. And as we know, in 1 second, we can easily make 10 to the power 8 operations. This is way less than that. So even the brute force solution that we discussed over here is going to work very well for the problem. But still, let us try to think of an optimized version of that. So one way to do that is, so if we are thinking of an optimized version, like what will be the way that we try to eliminate the extra complexity? We, like one way is, we should ideally not go over all of these. Like, is there anything we can do to not go over all of these characters? That is the only way that we can reduce the complexity, right? So if we try to analyze what is happening is, let's see the second character, that is 1 in the original string s. What happens? How many times does this one appear in the final grid? That is, how many times the one appears at the second location in the final grid? So 1, 2, 3, 4, 5, 6. Only 1 0 is there. Rest all the characters at that second place are equal to 1, which means that in the original string s, if a character at any position is 1, it will be part of the final grid how many times? N minus 1 times. 1, if the original character is 1, it will occur in the final grid n minus 1 times. Why n minus 1 times? Because in total there are going to be n such strings generated, and only in one of them is this character going to be flipped, and that is going to be the ith string, the second string. And if the original character in string s is 0, how many times is it going to appear as 1 in the grid? So let's say the first character over here was 0. Every time it appears as 0, only one time this character got flipped, that was for a1. So this means that if the original character is 0, it will appear as 1 only one time in the entire grid for that particular position. So therefore, if we try to analyze, say this was the original string, let me rewrite it: 0 1 1 0 0 0 1. So the string is of length 7, meaning that n over here for the string is 7. So let's count. All in all, what is going to happen is 0 is going to come once, plus 1 is going to come n minus 1, meaning 6 times. Again a 1, then 3 zeros, that is 1 plus 1 plus 1, and then last one, that is n minus 1, that is, so this is going to be equal to 22. So that is the final answer. Now let us try to code this solution. Bits standard C++.h. Okay, so what are the inputs that we have? The first line is going to be the number of test cases, then for each test case an integer n, and then the string of size n. Okay. The constraints are pretty low, like on the smaller side, so we can use int as the data type. We don't need long int. Then let us start the loop for the test cases. We have taken input of the number of test cases. Now for each test case, we need to input the size of the string. And then what do we need to do? We need to input the string itself. So let's input the string as well. Okay. Now let's say our result is the one that we are trying to compute, and we'll initialize it to 0. Now what do we need to do? As per the algorithm that we discussed, we just need to iterate over the string s. So you can just say this as n because you already have the size of the string. Okay. Now if the character at the ith position is 0, okay, then what do we do? If the character at the ith position is 0, this means that for that particular position in the grid, we would see 1 only one time. So we will add 1 to the result, and else condition means that if the character at that position is 1, then we will add n minus 1 to the result, because in the final grid we are going to see 1 all the time except just for that one string where that 1 gets flipped to 0. That is all. We have the result computed. Let us print this out to the console, and then let us try it out for the sample inputs as well. This works fine or not. Five zero five two four 50524. Let us also try to submit this code and see if this works. So let's go submit, choose the problem. Okay. So yeah. That is all for this video. Let me know if you want me to take up any other such coding questions.